A top embedding model can absolutely make your RAG system worse.
Yes, a strong benchmark score can hide a weak match to your domain, and that gap shows up as bad retrieval, shaky answers, and false confidence.
So, this is not about who wins a public test. It is about whether your search layer actually understands your documents.
Exactly. Programmers often see one number, assume semantic search is solved, then wonder why the assistant misses the right chunk, sitting 3 lines away from the answer.
Give me the trap in plain English. How does a model look brilliant on paper and still fail in production?
Because benchmarks measure performance on the benchmark, your corpus has its own language, abbreviations, writing habits, and relevance rules. If those differ, the score can mislead.
Concrete example.
Say you build RAG for internal incident reports at a payments company. Public benchmarks may reward broad semantic similarity. Your reports are packed with terms like soft decline, capture retry, MID mismatch, issuer stand-in, and ticket shorthand. If the embedding model does not place those terms and their surrounding patterns correctly, retrieval pulls generic payment docs instead of the exact incident with the real fix.
And then the assistant sounds smart while being wrong in the expensive direction.
Right. It retrieves plausible context, not decisive context. In RAG, that is the difference between a fast answer and a costly hallucination wrapped in confidence.
You use the phrase domain fit. Define it tightly.
Domain fit means the embedding space preserves the distinctions that matter in your domain. Not language in general, your domain. The model should make truly related documents land near each other and keep dangerously similar but irrelevant ones apart.
So not just does it know the words, but does it know what differences matter?
Exactly. In healthcare, dosage change versus diagnosis change matters. In legal, draft clause versus signed amendment matters. In source code, auth token refresh and session invalidation may be neighbors in meaning, but a bug fix may depend on one function name or one stack trace pattern.
That sounds subtle, and subtle is where systems lose.
Subtle is where winners separate. A team with better domain fit retrieves the right evidence faster, needs fewer re-ranks, burns fewer tokens, and ships a system users trust. A team that chases one benchmark number can spend months tuning prompts to compensate for bad retrieval geometry.
Let us go deeper on vocabulary, because that gets hand-waved a lot.
Vocabulary is not just rare words, it is overloaded words, abbreviations, product names, internal codes, and phrases that have a specific meaning only in your environment. The model has to place those correctly relative to each other and relative to ordinary language.
Example.
Imagine an IT support knowledge base. Users search for VPN drops after sleep, but the documents say tunnel renegotiation fails on resume for managed endpoints. A benchmark can say the model is great at semantic matching, yet if it does not connect sleep, resume, VPN drops, renegotiation, and managed endpoint policy in the way your corpus uses them, your retrieval misses the fix article and returns generic network troubleshooting.
So the miss is not random. It is systematic. The model keeps favoring broad similarity over the exact internal concept map.
Yes, and document style makes that worse. Some corpora are terse tickets, some are long policy docs, some are code comments, changelogs, tables, or bullet-heavy runbooks. Embeddings behave differently when meaning is spread across fragments, headers, or structured fields.
People talk about chunk size all day, but style starts even earlier than chunking.
It does. If your documents are short, repetitive ticket summaries, tiny wording differences can carry huge meaning. If your docs are dense technical manuals, section titles and nearby constraints matter. An embedding model that shines on clean, sentence-like benchmark passages may flatten those distinctions.
Which means two teams can use the same RAG architecture, same vector database, same chunking strategy, and still get opposite outcomes because the embedding model fits one corpus and not the other.
That is the strategic consequence. Retrieval quality quietly shifts power. The team with the better fit gets more accurate answers with less orchestration. The other team keeps adding re-rankers, custom prompts, filters, and guardrails just to claw back what good retrieval would have given them upfront.
Give me one practical way to test this without turning it into a research project.
Build a small retrieval set from your real tasks. 20 to 50 queries is enough to start, but make them painful queries. Include acronyms, edge cases, ambiguous terms, and wording mismatches. For each query, label the few chunks that are truly useful, not just loosely related. Then, compare or recall at K. Inspect the misses and look for patterns. Does the model confuse neighboring concepts, ignore internal jargon, or fail on a certain document style?
So, not a giant benchmark, a sharp benchmark that reflects your failure modes.
Exactly. If your RAG system serves compliance manuals, test cross-references, exception language, and versioned policy updates. If it serves engineering tickets, test stack traces, component names, and symptom versus root cause phrasing. The point is to measure the retrieval mistakes that actually change outcomes.
And once you see those mistakes, the leaderboard glow fades fast.
It should. The best embedding model is not the one with the prettiest public score. It is the one that makes your corpus legible to retrieval when the query is messy, the wording shifts, and the cost of a miss is real.
That is the uncomfortable part. Benchmarks can buy confidence, but only domain fit buys signal.
And in RAG, signal is the whole game. If retrieval does not understand your world, everything above it is just decoration.